x-axis, y-axis, and origin symmetry. Most of the textbook, they use a graph to explain this, but I have multiple ways to do it. So the way I do this is graph. Graph is always the best, but I always give myself a typical example. For the x-axis symmetry, the typical example that I always use is y equals to plus or minus square root of x. So we have the plus square root of x on top and then the minus square root of x below the x-axis. So how do you know that this is an x-axis symmetry? The answer is very easy. So you draw a vertical line. So you will see one point above the x-axis, that is x comma y, and then on the other side you see x comma negative y. So the language that I use is either the graph is either in quadrant 1, 4. So in this case is quadrant 1, quadrant 4, or quadrant 2, quadrant 3. Or you can use the language like up and down, up and down. So up and down, quadrant 1, quadrant 4. Up and down, quadrant 2, quadrant 3. All right. How do you know that this equation, the x minus y squared equals to 0, is an x-axis symmetry? Take a look at this. You have y negative y, right? So the way I test this is I will replace the y with a negative y to see if I can get back to the same function. So square that equals to 0. Once you square that, you have x minus y squared equals to 0. So even though you replace the y with a negative y, you still get back to the original function. So therefore, this is the x-axis symmetry. And then for the y-axis symmetry, the typical example that I use is y equals to x squared, which is a parabola. So y-axis, so let's compare x-axis and y-axis. So x-axis, when you test an x value, so let's say x equals to 5. Do we agree that x equals to 5 is in the entire vertical line? So that's why we test this graph using a vertical line. X equals to 5. Just imagine this. X equals to 5. So x equals to 5 is right over here. So it's the entire vertical line. So that's why I test the x-axis symmetry like this. So you draw a vertical line, you should see x, y, and then the other one is x negative y. So the y should be one positive, one negative, because that is either in quadrant 1, 4 or quadrant 1, 4 or quadrant 2, 2, 3. But for the y-axis symmetry, just picture this in your mind, y equals to 5. So y equals to 5 is a horizontal line, right? So when you look at the graph, you draw a horizontal line, you will get either positive, both positive y or both negative y, because the parabola can be either facing up or facing down. So that's why for the quadrant, I say it's either in quadrant 1, 2, which is in this case, or quadrant 3, 4. Which is an upside down parabola. So quadrant 1, 2 or 3, 4. Or the language you can use is left and right. Left and right. This one is up and down, up and down. So that one, you draw a horizontal line, you see both positive y and one negative x and one positive x. So the way I test this is I will just replace the x to the 4th with a negative x raised to the 4th minus y equals to 0, because this is a negative, this is a positive. So if I replace the x to the 4th with a negative x, that should get back to the original function. So negative x you raise to the 4th power, the negative sign will be gone, then you have x to the 4th minus y equals to 0. You get back to the original function, then this is a y-axis symmetry. Just use a parabola, either y equals to x squared or y equals to negative x squared, an upside down parabola that looks like this. That one is also a y-axis symmetry. So for the x-axis, up and down. For the y-axis, left and right. How about the original? The original is either in quadrant 1, 3 or quadrant 2, 4. I would just call that diagonal. Quadrant 1, 3 or quadrant 2, 4. Again, quadrant 1, 3 or quadrant 2, 4. The typical example that I use a lot is y equals to the cube root of x. That looks like this. X can be positive or negative. And then this one, if you have I will try to match the color. So this one, if you have x comma y, then on the other side you should have a negative x comma negative y. quadrant 1, 1, 3, or 2, 4. So the way we test this is we will replace both with a negative. So this is a negative x to the third. By the way, I already switched to a different function. If you graph x to the third, what is the graph looks like? The graph looks like this, x to the third power. So this is in quadrant 1 and quadrant 3. So this is a what do we have? This is a negative y, and then this one, since that is the third power, you still have a negative x, and then you divide both sides by -1, you get back to y equals to x to the third, you get back to the original function. So that's why this is an origin symmetry. Alright, so that's how you distinguish the difference between x-axis, y-axis, and origin symmetry. Let's go over this one more time. The x-axis symmetry is up and down, either quadrant 1, 4, or quadrant 2, 3, up and down. The y-axis symmetry, parabola, left and right, either in quadrant 1, 2, or quadrant 3, 4. And then the origin symmetry is diagonal, either in quadrant 1, 3, or quadrant 2, 4. Alright, so that is the end of this video. If you like the way I explain this stuff, give me a thumbs up. Truly appreciate your help, and I will meet you all in the next video. Signing out.